All right, so separate recording for the second half of today's lesson. We're going to start 9.4. Everybody have their tan sheet? Okay. This is what this lesson is about. Conics. Do you remember conics? We had circles, parabolas, ellipses, and hyperbolas, yes? Okay. Here's a little known fact. This had a directrix. That is not the little known fact. We good with that though? Okay. This thing actually has two directrix. That's really weird, and you don't really have to know or understand anything about it. That doesn't make a lot of sense to me. This makes sense to me, that there's a directrix in here somewhere, yes? Because that kind of makes sense that there's little parabola shapes opening away from it, okay? Yeah, yes. That's a great, okay, two little parabolas that are going together, so there's these, okay. I like that idea. All right. We also spent a lot of time talking about eccentricity before, or a little time anyway. Does anybody remember about a parabola, what the eccentricity was? It was just one, you had to memorize that, right? The eccentricity of an ellipse, the definition is the distance between the foci, it's actually 2c, but divided by the distance between the vertices, which was 2a. Was this bigger than 1 or less than 1 for this? If you take the c's over the a's, you get less than 1. It says all over the notes that you have to memorize that, but you remember it's on the back of the pink sheet somewhere it says that? Okay. Last one, hyperbolas. When you had a hyperbola, again, the eccentricity is the distance between the foci divided by the distance between the vertices. Guess what? Which is longer? So this time, when you did this divided by this, you got a number greater than 1. Remember that? Okay. So this made it an ellipse. This made a hyperbola. We're halfway through the lesson. Okay? The second thing you need to know, look at all these equations on your tan sheet. See this on your tan sheet? It's on the back of the tan sheet, the side that doesn't have all the, you find it? Okay. I want you to look at all this and tell me what you see. This is how you put these on the calculator to get an ellipse or a hyperbola or a parabola in polars. If you wanted to graph an r equals equation and make it be a parabola or be a hyperbola, you'd have to do one of these four right here. What I want you to look at is tell me what's the same about these four, what's different. Okay, the first two have cosine, the bottom two have sine, yes? Some of them have plus and some of them have minus. What do they all have on top? And what do they all have on the bottom? 1 plus. That 1 plus is really important. This is how I remember that I relate it, and I shouldn't say this on camera because I don't really know that this is true. But do you remember how we all had to make an ellipse or a hyperbola equal 1 at the end? So I think there might be some relationship there. I don't know. But we have this one thing down here, okay? The eccentricity is going to come from here. Now, I know there's an E on the top as well, but there's going to be a 1 number on the top when we're done here, and that 1 number is going to be E times D, okay? So the eccentricity is down here. I want you to look a little further over here. Do you see it says the directrix is a vertical line, x equals D? Okay? Cosine and x. The next one, cosine and x. Then it says, for these two, it's a horizontal line, y equals, and those had the word sine, right? You don't have to memorize this. You get to use the sheet, but I'm trying to make you see a little pattern here, okay? The other half of the pattern, a plus in the middle here was a positive D. A minus in the middle here is a negative d. The e itself is always positive, and so is the d. But when there's a plus here, you put a positive d, and a minus, you put a negative d. All right. All crazy business. I'm going to skip all the notes, and I'm going to go to number 1. If I say this is equivalent to ED over 1 minus E sine theta, what can you tell me right now? E equals 1/2. You just told me the eccentricity. What type of conic is it if E is 1/2? Okay, now, Sarah's way ahead of us. She's right. But up here on top, we have ED equals 2, yes? We got to do a little work here. ED equals 2, but you just told me E is 1/2. So D is 4. That's what Sarah said, okay? Now we have to figure out this equation of the directrix business. And if we go to the sheet and look, what does it say when it's 1 minus E sine D? Y equals negative D. Remember my hint? It's sine and it has this minus here, so it's Y equals minus. Okay, so the equation is simply Y equals negative 4, and we're done. Do you see why I said we could do this lesson in 5 minutes? Okay. There's one little thing they make a little bit harder, but let's try one more that's super easy. What about this number 2? Okay, E is 3. So up top, ED is 3. If we put in E is 3, so D is 1. Okay, so the answers to the questions, eccentricity is 3, which makes it and when we get the D, we set the top, E times D, we put the E in, we got 3 times 3, D is 1. It was sine, so it's Y equals, and it was plus, so it's D, Y equals 1, yes? Okay. That's the directrix. Just, you get to do this very rotely on the quiz, but just to humor me so that it makes a little bit of sense to you, I think I even have this already typed in. I typed this equation in, y equals, or I'm sorry, in polars. R equals 3 divided by parenthesis 1 plus 3 sine theta. Everybody okay? Now, if I left it in connected mode, it connects all the dots and you get the actual asymptotes and it's really hard to see. So I turned on the called dot mode, and this is what the graph looks like. Do you see the hyperbolas there? It's kind of hard to see. Let me see if I go over it. Can I go over it with the marker? Do you see the dots? It's here and here. Okay, I didn't do too bad, right? Now, we said its directrix is at y equals 1. Y equals 1 is a horizontal line right there. I didn't do quite as good. But does it make sense that that could have a directrix at y equals 1? Okay, just trying to show you that this is how this graph really is a hyperbola. All right, here we go. What happens when we get to number 3? There's not a 1. Remember I told you that 1 was really, really important. Nothing works until there's a 1. Okay, so what we're going to do is we're going to divide the top by 2 and the bottom by 2. And why did I pick 2? Because I want a 1 right there. Okay, so 4 divided by 2 on the top becomes a 2. But down here, remember, we have a 2 over 2 and a 3 over 2 sine theta. So it becomes 2, 1 minus 3 halves, and you can use a decimal, I don't really care, sine theta. All right, so what do you know now? E equals 3 over 2, which is greater than 1, so it is hyperbola. Now we got to do a little work to find D. Before everybody's shouting things out, I want to make sure everybody gets how we do this, okay? The top is ED, so ED is 2. Everybody all right? And then I'm going to put in E is 3/2. And then to find D, I got to multiply by the reciprocal. Are you okay with where we're coming up with that business? So we're going to divide this over here, and which flips it over and makes it a 2/3. Then it's 4/3, right? 2 times 2 divided by 3 is 4/3. So if D is 4/3, got to look on my sheet, and the formula, when I'm going to show you, the formula here, if this one was a, I already, was it a 1 minus sign, so it's this guy? So it says to use y equals minus d, okay? Are we good where I'm getting that? So the asymptote, which I have no room to write, or the directrix, I'm sorry, not asymptote. Directrix is y equals negative 4/3, yes? Okay. I want you guys to try 4 and 5. We'll save 6 for tomorrow. Try 4. What are you going to divide everything by here? 4. So you actually get a fraction on the top. Jared, tell me one thing. Tyseer, tell me one thing. Right. It's also not a parabola because parabola is exactly 1, okay? So that makes it, good job. All right, then the tricky business comes in, right? E times D is 3/4, and I'm going to put a 1/2 in for E. So if I multiply this by the reciprocal, what do I get? 3/2. So the equation of the directrix, anybody have it? X equals negative 3/2, okay? There's not one that's been a parabola, has there? I think I skipped the only example of a parabola. This one right here was a parabola. How did I know it was a parabola? Because it was 1 plus plain old sine down here, so the eccentricity was 1, and so that one was a parabola. We haven't seen another one that's a parabola. Who's got 5 done? We divided by 4, which made 2 over 1 plus 3/4. What did you have, Sarah? Equals 3 over 4. Ellipse. 3/4 D equals 2 meant D equals 8/3, so Y equals 8/3. Okay,